we want to determine the derivative of the given function. The first thing we should notice here is that our function is a product of two differentiable functions. So if we call the first function f and the second function g, the product rule of differentiation states the derivative of f times g is equal to f times g prime plus g times f prime. Or we can say the derivative is equal to the first function times the derivative of the second function plus the second function times the derivative of the first function. So let's apply the product rule to determine this derivative. So we'll have the first function, which is 6x to the second minus 5x plus 2 times the derivative of the second function, which is 12x to the third, the derivative of 1 would be 0, plus the second function times the derivative of the first function, which would be 12x minus 5, and the derivative of 2 is 0. And just to emphasize this, we had the first function f times the derivative of g plus g times the derivative of f. So now that we have found the derivative, the rest is algebra. We have to distribute 12x to the third, and then we have to multiply these two binomials and then collect like terms. So we'll have 3 products here, and we'll have 4 products here. So we'll have 72x to the fifth minus 60x to the fourth plus 24x cubed. And over here we're going to have 36x to the fifth minus 15x to the fourth minus 12x and plus 5. And now we'll collect like terms. There are 2x to the fifth terms, so that's 108x to the fifth. There are also 2x to the fourth terms, so watching our signs here, we're going to have minus 75x to the fourth. And there are no other like terms, so we have 24x cubed minus 12x plus 5, which would be our derivative function. Now if you're wondering at the very beginning if we could have multiplied this out and then found the derivative using the power rule, and the answer is yes, we can, but as these functions get more complicated, applying the product rule will be the preferred method. But I will show multiplying this out on the next slide. So if we took the time to multiply this out, this would be the function in expanded form, and then if we applied the power rule given below here, we should notice that the derivative function is exactly the same when using the product rule. So you may find it helpful to take the time to do this problem both ways just to verify that both methods do work. I hope you found this helpful.